Hello friends, this is another lecture on Bessel's functions. In this video I'm gonna prove this formula. Okay, I have already shown you how to prove this formula in the last video. Okay, recurrence formula number 1, this one already proved, and I have also solved a problem which was asked in June 2023 CSI net exam using this formula, right? So now today we're gonna prove this remaining formula. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. that's my Insta ID. You can follow me on Insta. So now let's start. So recurrence formula number 2, this is the formula number 2. So how to prove this formula? So in order to prove this formula, so let me first write the Bessel's function. So we know that the Bessel's function is given by this is the Bessel's function, right? So before you watch this video, I would like to suggest, please do watch the previous video. Okay, last video, link is in the description box. Okay, so this is Bessel's function. Now let us differentiate both sides with respect to x. Okay, if we differentiate both sides with respect to x, then what we're gonna have, differentiating both sides with respect to x, so ddx of jn, that's gonna be z dash n. Okay, so I have written this z dash n means ddx of jn, right? That's it. So here you see on the other side you're gonna get this, right? Now here you see, now if we apply if we differentiate this, then what we're gonna have, so here power is n plus 2 to the power r, right? If you differentiate this x by 2 whole to the power n plus twice r, then what you're gonna have, if you differentiate this, then you will get n plus twice r into x by 2 whole to the power n plus twice r, then this power will be reduced by minus 1, because we know that ddx of x to the power n is n into x to the power n minus 1. Just we need to apply that. And again, as it is not only x, it is x by 2, then again you have to differentiate this x by 2. If you differentiate this x by 2, then you will get only half. Okay, you will get half. So that's why, so on differentiating we have got this, right? And one more half should be there. Okay, so hope you have understood this. So now what we can do, let us multiply both sides. Before that, let me write this one in this way. Just give me 1 second. Okay, so here you see, okay, now let us multiply both sides by x. So here also I have multiplied x on the right hand side. Here you can see, on if you multiply x on the right hand side, this half becomes x by 2, right? And here also we have multiplied x, right? So hope you have understood this. And then what we're gonna have, if you multiply these two, x by 2 to the power n plus twice r minus 1 and x by 2, then what you're gonna have, then here you see n plus twice r minus 1 plus 1. Here nothing means power is 1. Okay, so then minus 1 plus 1 gone, we're gonna have n plus twice r, right? So hope you have understood this. So that's why, let me simplify. Then what we're gonna have, we're gonna have this, right? That's what we're gonna have, right? So now let me copy this and let me go to the new slide. Okay, let me copy this last step and let me go to a new slide. Okay, so that I can explain further. Okay, so here you see, this is the last step. This is the last step here. Okay, so this is what we have got. Now here you can see this term n plus twice r, this can be written this way, just n plus twice r, this can be written as twice n plus twice r minus n, right? We can write this way. Okay, then this implies, okay, so let me rewrite this in this way, right? Hope you have understood this. Now you see, now you split this term. If you open this bracket, then what you're gonna have? So this whole term will be multiplied to this part, then this part, right? So hope you have understood what I'm trying to say, right? So then what you will get? First, you see, first multiply, if you just open the bracket, okay, then what you're gonna have? You're gonna get this here, twice n plus twice r, and the should be multiplied with minus n also. So here we're gonna get this. Right. So here you see what we have actually done here. Now you see this term can be written this way, right? We can write this way. This n plus twice r, this n plus twice r into, we can write this, we can write this way, n plus twice r into this, okay, we can write this term into, okay, let me show you, this term into this whole term into n plus twice r. So if you multiply, then if you write this one in this way, that twice n plus twice r minus n, then if you multiply this one with this, then this should be multiplied with this term first, then with minus 1, right? That is what we have done here, right? So hope you have understood this. So now here you can see, here this 2 can be taken common, so we're gonna have n plus r, and we have a property such that gamma of n plus 1 is n into gamma of n, okay? So if we apply this property here, you can see in the denominator, this gamma of n plus r plus 1 can be written as n plus r gamma of n plus r using this property, right? So hope you have understood this. Then here n plus r cancels, so this implies this, okay, this implies this, right? So here you see this is Bessel's function. Here you can see this is nothing but Bessel's function, so we can write Bessel's function Jn, right? So we can write here, since this part is nothing but Bessel's function, okay, this is, so this can be replaced by Jn, right? This is Bessel's function. So that is what we have done, right? So hope you have understood this. So now you see, now let me copy this. So here this is Bessel's function, okay. Now let me, here you see, instead of this part we have replaced this by Jn, okay. So now let me go to the next slide. So here is the last step we have got. Let me rewrite the last step, okay. So this is the step we have got. Now here you see what we can do. Okay, let me write here minus and then. Now you see, if we write if we write x here, then here we can write 2 by x, right? Hope you can understand this. So here I have written x, here also I have written, so if you cancel x, then again you're gonna get this term, right? So hope you have understood this. So now you see, now if you multiply this one with this, then what you're gonna have? If you multiply these two, so this, then if you simplify this, then what are you gonna have? Let me write here, okay. Then this n plus twice r, n into this, that's gonna be minus 1, okay. So here you see, if you simplify this, then x by 2 n plus twice r minus 1. So that is what we have written here when we after multiplying this one and this one, right? Hope you have understood this. Okay, this is very simple multiplication. Hope you can do these things. Okay, so now you see Bessel's function, the definition of Bessel's function. If you write that here, you see, so this is the Bessel's function, right? Okay, if you replace this n by n minus 1, then this n must be also replaced by n minus 1. Okay, then this gamma of this n, this part can be written as gamma of n minus 1 plus r plus 1, right? And here you see this is nothing but equal to gamma of n plus r, right? Minus 1 plus 1 cancels here, minus 1 plus 1 cancels. Okay, and here the power, here also if you replace the n minus 1, if you replace the n by n minus 1, then this term gonna be equal to x by 2 whole to the power n minus 1 plus twice r, right? Which is nothing but this term here, you can see. Okay, so this is nothing but n minus 1 plus twice r, right? So hope you have understood this. So you can say that this is j n minus 1. So you can write this j n minus 1 because we have replaced. So this term is the result obtained from this Bessel's function if you replace the n by n minus 1, right? Hope you are getting my point. So if we do that, then what we're gonna have here, x into j n minus 1 minus n into j n. This term is this one, right? Hope you have understood this. So this part is replaced by j n minus 1. So, or we can write this way. Okay, so this is the second recurrence formula. Okay, so this is what we needed to prove. This is the second recurrence formula. Okay, so now let me show you how to prove the third one. Okay, so let me take a new slide. So recurrence formula number 3. So this is the recurrence formula number 3. Okay, so first let me take the recurrence formula number 1. So what was the formula? Let me write the first formula. This was the first formula. Okay, and the recurrence formula number 2, this was the recurrence second recurrence formula. Okay, this is recurrence formula number 2. Okay, now this is equation number 1, equation number 2. Now let us add these two equations. If we add these two equations, these two gives 2x j n dash is equal to, these two terms keep gone, so we have got x j n minus 1. Let me write the positive term first. Okay, then negative term, this one. Okay, so hope you have understood this. So here you see, adding these two, we have got this term, right? Hope you have understood this. So now let me clean these things. So dividing both sides by x gone, and this gonna imply 2jn dash is equal to jn minus 1 minus jn plus 1. So here is the third formula, right? So third recurrence formula is proved. Okay, so this is the third recurrence formula, right? Now what was the fourth recurrence formula? Let me write that here. This is the fourth recurrence formula. So how to prove this? So here you see, let me prove this formula. So if you add these two equations, equation number 1 and 2, if you add these two equations, subtract these two equations. Now here you see, in order to prove the third recurrence formula, we have added equation number 1 and 2, right? If we subtract 2 from 1, okay, first just do, let me write this equation 1 and 2. Okay, 1 and 2. Let me subtract equation number, that means the recurrence formula number 2 from recurrence formula number 1. Okay, if we subtract these two, so when you subtract, then you should consider the here you see, in equation number 2 we're going to consider the positive term as negative term as positive, because we are subtracting 2 from 1, so negative sign before equation number 2, so all the sign before the terms in equation number 2 will be changed. Okay, so here you see this is positive, so we have taken as negative, right? That's how we have to deal with this. So now So here you see on the left hand side these two cancels, so we have got 0 here. Then on the right hand side, as we have taken this one as positive now, so these two terms should be added. So adding these two, what we have got, 2n jn, right? And on the other side this is negative now, this is also negative, okay? Because this is, though it is positive now, we need to consider this is negative because we are subtracting equation number 2, right? So there will be a minus sign before this, so positive, negative, negative. So here we have negative, this is also negative, so we have to add the two terms. So here we have got this result, right? So now you see, sorry, just give me a second. So here you see these two are different terms. So one is j plus 1, jn plus 1, jn minus 1. So we need to write separately like this. So then this equation implies, if you simplify this equation, you're gonna get this, right? So I don't think I need to explain this kind of simple simplification, right? So here is the, so now let me copy this and let me go to the new slide, right? So here what we can do, we can take this x common in order to obtain this formula, right? So let me go to the new slide. So here is the last step. Now let me take x common from both terms, from these two terms, right? So here you see this is the recurrence formula number 4, okay, proved. So now let me prove the fifth recurrence formula. This is fifth recurrence formula, ddx of x to the power minus n jn minus x to the power minus n jn plus 1. So in order to prove this, what we're going to do, first let me write the recurrence formula number 1. Which one is this? This is the first recurrence formula that we have already proved in the in last video, right? So here you see what we're going to do. Let me write that one again. So here we need to multiply one thing, that is let me multiply both sides by x to the power n minus 1. So I have to multiply each and every term by x to the power n minus 1, right? Then what we're going to have, if you multiply this and this, then you're going to have x to the power minus n, right? J n dash is equal to, again here you see, let me write the n first, then x to the power n minus 1 j n, and here again if you multiply these two, then you're going to have x to the power minus n j n plus 1, right? So now here you see, let me bring this term to this side so that I can write this. So now let me copy this, and here is the last step we have got. This is the last step we have got, okay? Now you see ddx of x to the power n minus 1 jn is equal to this. This is the formula that we are to prove. This is the formula that we are to prove. Now if you see the left hand side, this side, so if you differentiate this term, here you see applying u into v, if you differentiate this applying u into v rule, that means the product rule, derivative of u into v is u derivative of v plus v derivative of u. If you apply that, then derivative of the first function x minus, here in this case u is x to the power minus n, u derivative of v is jn, its derivative is z dash n, then plus derivative of the first function, that is x to the power minus n, into the second function, okay? So first function derivative of second function, second function derivative of first function. And if you differentiate this, what you're going to have, if you differentiate this, what you're going to have, so we're going to have this step, right? So here we have applied ddx of x to the power n, so here this minus n comes, this is power, this power is minus n, so minus n minus 1 here. So here you see the left hand side of this equation, you can see this is nothing but this result is the left hand side of this equation, right? So and this result is nothing but what, derivative of ddx of x to the power n minus 1 x to the power n x to the power minus n into jn, right? So we can replace this by ddx of ddx of x to the power minus n jn, right? So if we do so, then what we're gonna have? Then we're gonna have this. This is what we're gonna have, right? So this is the equation this is the formula that we had to prove this. So now let me show you how to prove the recurrence formula number 6. So this is the recurrence formula number 6. Let me write that formula here, you see. So how to prove this? So here, to prove this one, we're going to use the recurrence formula number 2. This is the recurrence formula number 2, this one. Okay, so here what we're going to do, let me write that step again. So here we need to multiply x to the power n minus 1. In the previous case, to prove this one, we had multiplied x to the power minus n minus 1. Here we have to multiply x to the power n minus 1, right? By with each and every term, we're going to multiply x to the power n minus 1. Okay, so if you multiply this one with this, then you're going to get x to the power n, right? And if you multiply this one with this, then again you're going to have x to the power n. Let me copy this step and let me go to new slide. So here is the last step we had got. Okay, so now let me simplify this. So here x to the power n j and s is equal to minus n is written first, then x to the power n minus 1, then jn, then next term plus x to the power n. Okay, after multiplication, product of these two, we have got x to the power n, then jn minus 1, right? Now what to do here? Jn this, then here you see. So what to do? We need to transfer this to left side, then this sign will be positive here. Okay, this sign becomes positive now, this one. Okay, and on the other side we have got x to the power n jn minus 1. So here you see left hand side, this is nothing but ddx of x to the power n jn. If you differentiate this, let me write it completely first. Okay, if you differentiate x to the power n jn using the product rule, using this product rule, okay, then you will get this. Okay, you will get this, right? So hope you know how to differentiate this. So ddx of x to the power n, we know that n into x to the power n, here x to the power n minus 1, sorry, and jn is written here, right? So this is, here you see, this x to the power n is taken as u, this is as v, then this is u derivative of v, then this is v derivative of u, right? And ddx of x to the power n into x to the power n minus 1, and this result is nothing but the left hand side, this left hand side, here you see. So we can replace this by this term, right? So hope you have understood this, because this step is obtained by differentiating this, right? So here is the formula. So here is the 6th recurrence formula. So hope you have understood this. Thank you for watching. See you in the next video. Okay.